So hi guys, welcome back. In this video we are going to solve today LeetCode daily challenge. The name is maximum number of k divisible k components. Okay, so let's read the problem statement and try to observe the details in the question. Okay, so there is a given a undirected tree which is basically n nodes, and nodes are level from n0 to n minus 1, given a 2D integer array, edges basically n minus 1, where edges a each edges I is basically indicating that edge between a to b. Okay, and there is a tree basically. Okay, so this is a undirected tree, so it is a graph problem. Edge, it is indicating that it is a graph problem, and node are 0 to n. Okay, fine. And okay, so it is, as it is a graph problem, it is not going to contain a cycle, it's for sure. And you are also given a zero index integer array value, which is basically the length of the n, where value I is the value associated with the ith node and the integer k. Okay, integer k, and we have to split that array. Okay, possibly empty, by removing a h, possibly empty. Okay, from the resulting component have all the value divisible by k. So yes, so in this example if we observe, so this 1 and 3 node value will going to be the 8 and 8 and 4, and this is going to 12. 12 is divisible by k, k is 6. So yes, this component is divisible by 6, and this component also going to divisible by k, 4, 4, 2 and 2. So 4 plus 1 plus 1 will going to 4 plus 1 plus 1, so this is 0, so it will going to 1. So 4 plus 1 plus 1 will going to 6, and 6 is also divisible by k. Okay, so how are we going to solve this question? Okay, so and we have to return the maximum number of component that is valid and can be split. Okay, how many component we are able to going to achieve. Okay, so let's see the constant is looks fine. It is in 10 to the power 9, 10 to the power 9, 10 to the power 4. Okay, and sum of the values is divisible by k. Okay, let's see, some of the values are divisible by k. So 1 plus 8, 10, it is 18. 18 is divisible by k. So it is state that in the question given that the all the value already in the tree are the values of the all the nodes are already divisible by k. So let's see in the question, observe in the question. Okay, so as this is a tree, all those are value, the tree not going to contain a cycle, and this is okay, so this values array are already divisible by k. Fine. Okay, fine. And okay, to solve that question, let's solve let's solve this question with a simple tree. Okay, for example, all the values in our tree will going to be what, going to be all values are going to be 6. Okay, so how are we going to split that? Okay, how are we going to split that? So if are going to what we are going to do, let's do a dfs, simple dfs to split that. Okay, first we are reach at the 6 value. When we reach at the 6 value, when we reach at the 6 value, 6 value is already divisible by k, so we are going to split that from the tree. But there is a split that from the tree, and then we will going to the second node. Second node also divisible by k, and we are also going to split that from the tree, and we are going to split that. Then we are going to go to the 6, and this is going to also split that from the tree. Okay, fine. This is we are going to do that, but there is a issue. For example, our tree is looks like this. Tree is looks like this. This is 6, this is 9, and this is 3. If we are reach at this node, and we are trying to we are try to split that removing by these two edges and split this node from the tree, then this individual node are not divisible by k, not divisible by 6. Okay, so this is going to be a invalid, this is going to be going to give us a wrong answer. So how to handle that? To handle that, what we are going to do, we are first doing the top down approach. This top down approach is not working for us. So what we're going to do for that, we are going to do the bottom up approach for this tree. So let's see, this is 6, this is also going to 6, this is 6, okay, 6, and this is 6, fine, this is 6, perfect, okay. So what we're going to do, as we are performing the bottom approach, we are going to do the bottom up approach, okay. In the bottom up approach, what we're going to do, first we are going to the bottom. At the bottom, we are going, what we are going to do, we are going to find the current sum. Basically the current sum is basically 6, and we are going to check, is this divisible by k. If this is divisible by k, we are going to split this tree, split the node from the tree, okay. Remove this edge, and we are going to return the sum. When we have received this sum is 6, we have already have 6, and we are going to this node, this is also divisible by k, and we are going to split this and return the 6. This is 6, this is 6, 6 plus 6 plus 6 is 18, and 18 is also divisible by k. So we are going to remove this node from the, remove this edge from the tree, okay. So yes, in this way we are able to achieve the result. But there is a case, okay, there is a case. Let's consider this example. So let's consider this example. So we are start from this node 1, we are at the 1, the value will going to be the 8. 8 is not divisible by k, so we are going to this, go to the bottom, we reach at the 4, 4 is not divisible by k, then we are return the 4 from to the 2, then we have 4, we currently have 2, and we are go to this node 0, 0 is 1, 1 is not divisible by k, so we return the sum will going to be the 1. So in that case, we are going to have our current sum is 6, and 6 is divisible by k, k is 6, it is divisible by k, so we can remove this previous edge from the tree, okay. We can able to erase the previous edge from the tree. After that we are going to, we can return two things. First thing, we can return the 6 to the parent of this node, but if we return the 6 actual sum, this will be going to the very big, so to handle that, we are going to return the k, basically value after mod k. So we're going to return this k value, this will go to the 0, we return this to the top will going to receive 0, and our current value is 8, and we are going to this 3 will going to our 4, 4 is not divisible by k, it will going to return, and it will be 4, then the sum will be our 12, and 12 is divisible by k, okay, 12 is divisible by k, so it will going to be a valid tree, okay. So this DFS approach is working for us, so it is a pretty tricky problem to come up with this solution, that we are going to do a DFS, and every DFS we can check that it is a valid tree or not. When we found that it is a valid tree, we are just going to increase our count, okay. So yes, this is a very pretty tricky problem, as it is a hard problem. So yes, so let's see the code, how it is we are doing, okay. So what just I am doing that, this is a, as it is a graph problem, so I am just created a graph, but it is a graph with not containing a cycle, so it is basically a tree as it is given in the question. So I have created another map, I am just adding the edges to the adding all the edges and creating that adjacency list. After created the adjacency list, I created a counter variable which will going to increase when we have hit that condition that sum will be divisible by k, okay. So this DFS function I have written. After that, I am just returning the count, and I am just passing that count as a reference to this function, okay. So this DFS function, in the DFS function I am just receiving the adjacency matrix, sorry, adjacency ordered map, and the counter variable and the values with the reference k, with the reference this current node and the parent. I am just passing this parent to avoid the cycle. So as it is a undirected map, as it is a undirected graph basically. So when we reach at this node, so we can also, there is a chance that we are going to go to the previous node that it is come from. So we have to track the parent that we are not going to visit that node again. Okay, we are not going to visit that node again. So I am just passing the parent. For the initial case I am just pass a invalid parent. So we are not going to loop this current node again and again. Okay, so yes, so we have received all those elements. So current sum will going to be the current values of the current node. So I am getting that current sum, and I am just navigating all the nodes. I'm just iterating all the nodes and checking that if this is not a parent of our current node, then I'm just doing a DFS, and this DFS will going to return our the sum basically of their child. It will return the sum. I'm just adding all the sum, and after we added all the sum, I'm just doing a mod with the k. If this mod is equal to 0, it means it is divisible by k, and we can remove that edge from the tree. And when we remove that edge, we are just increasing the count and returning the sum. So we can return the sum, or we can return the mod value. Okay, so if you return the sum, then sum will going to be the continuously going to the very large, and it is not able to handle by the int variable, int data type. So I am just returning the mod, so it will able to handle by the 32-bit integer. Okay, so yes, so this way I am just returning the sum, and it will going to eventually receive by this sum. And this is a recursive DFS approach. So the code is not that big and hard to understand, but thing is that we have to observe that this is a tree, and all the values of the node are already divisible by k, and come up with that solution that we can do a DFS and remove and DFS should be bottom to top, and remove all the edges which is divisible by k, which children are divisible by k. This is a pretty bit tricky question, but yeah, so this is a question that we have to solve, and we are going to achieve that by solving again and again, and finding the pattern again and again. Okay, so yes, this is all about it. I hope you learned something. If you learned something, do subscribe, like that video, share that video if you want to. Thank you so much.